Okay, good evening. We have a new vector problem here today. We're going to have two ships that head in different directions, and one ship gets his engine fails or what have you, and then the other ship has to rendezvous with them and help them out. Okay, so that's what we have today. All right, let's see. Two ships leave port at the same time, 12 o'clock noon. Ship A proceeds at 12 knots on a course of north 40 degrees east, while ship B proceeds at 9 knots on a course of south 65 degrees east. After 2 hours, ship A loses power and radios ship for help. Well, the other ship B, I guess. How far and on what course must ship B travel to reach ship A? How far and on what course? How long does it take for ship B to reach ship A, and at what time does he get to him? All right, so first thing, let's see what this south 65 east looks like. Okay, all right, south. Now let's go 65 degrees east. I don't have my protractor exactly, but I'm going to guesstimate it. And I'm going to say that, well, that's 90, and it's probably 65 is about right there. Okay, so there's my 65. Okay, let's get this guy. No, that's ship B. All right, ship A is going on north at 40 degrees east. So let's see. If this is north, now he's 40 degrees east of north. So that would almost be a 45. So I'm saying that's about like that. So there's my 40 degrees. And that's east of north. So there's ship A. And there's ship B. Okay, so I'm sorry, I made a complete error here. Ship B is going on south 65 degrees east. So it would be the opposite here. There you go. There's your east. There's ship B. So there's east and there's B. Okay, so ship A is heading off kind of to the northeast, and ship B is heading to the southeast. All right, so from the home port. So I'm gonna make a home port here and try to do this graphically just to see how it works out. So here we go. There's home port. I'll call it O, as you know, for the origin. And now I don't know the distance, but I can calculate the distance. So let's start out by calculating the distances. Okay, so in 2 hours, we're talking about where would ship A be if he goes off on this direction here. Okay, so in 2 hours, we have 2 hours over 1. This is for A. He's going to travel at 12 knots, 12 nautical miles per hour. That's what a knot is 1 nautical mile per hour. So it's 12 nautical miles per hour. And the hours cross out, and I get 24 nautical miles. That's for ship A. Okay, for B, 2 hours over 1 times, he's going 9 nautical miles. Okay, 9 nautical miles. So nautical miles per hour. And there you go. And now we have 18 nautical miles. All right. So that's the lengths of these. And I always tell everyone to use the metric. It's just so much easier. Otherwise, you're dealing with 16 graduations versus decimal graduations. Much easier. So it looks like where I drew my my O maybe is not going to be too helpful, but I have to figure out if I have 24 and 18, what's a good unit to use here? Well, I could use these millimeters, and it's really, really tight. as you can see, pretty tight. So I'll just say that if let say 3 millimeters equal what, 10 nautical miles. Okay, that's my scale that I'm going to use. 3 millimeters equals 10 nautical miles. All right, so I'm going to go with that 3 millimeters is 10 nautical miles. So what would 24 be? That'd be over 1, and I would get nautical miles crosses out, and I would get 7.2 here. Okay, now I do over 1 times 3 millimeters is 10 nautical miles, and I would get, let's see, 18 times 3 divided by 10, 5.4. All right, that's millimeters. Okay, so I'm kind of going to have to move my O, and I'm going to move them over here and just scratch that out. All right, here's O. All right, let's get this bearing here about 40 degrees, okay? 40 degrees, and we need to put out a line at 7.2 from where we are here. So I'm going to draw that one. Okay, and there's the head of where he's at. And then down here, I'm at, so if this is north and this is south, this angle here is 40 degrees. Okay? All right, now, I'm going off at south 65 degrees. So here's south, here's north, here's south, but 65 up. So there's 90, so it's a little more than 30. So I'm gonna draw 5.4. Okay, and there's the head of that one. So there's A, and there's B, and these are vectors. They have a length and they have a direction. Okay, so this is 65 degrees right there. All right. Now, the problem is we have to find out what direction this guy B has to go in to find A later on. And also we have to determine what bearing would he be traveling on, and then how long does it take him to get there, and what time would he get to him. Okay, so this is the problem, is getting this new vector here, which I'm going to call R as for resultant. Okay, but first I'm going to put a point at these locations. And in vector terminology, when you're starting from 0, 0, you usually give kind of like a less than and greater than in coordinate system. I'm looking for the x, y coordinates of these points. And then what I'm going to do is I'm going to drop those x, y coordinates into the old distance formula, which say in this case D, which is really my R vector, magnitude, right? Magnitude of R, the distance between these 2 points, would be given by the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, so in this case I can call 2 B and 1 A, whatever you like. So let's get these xy coordinates. All right, so looking at A, I'm going to try to break him up into his into his XY components. So if I come over purely east, I can, oh, now let's do, and let's use this 40 degrees so we don't even have to calculate anything else. I'm going to go up, and then I'm going to go over. Okay, there you go. And that's how I got to him. So head to tail here. And these two vectors must equal this other vector. And by the way, these are at 90 degrees. They're the rectangular component vectors of A. All right, so now I could say this side length would be equal to the length of the hypotenuse, which would be, as I calculated, 24 nautical miles. And this one here is 18 nautical miles. Okay, so I forgot to add those in. So this would be 24 nautical miles times, well, this is the opposite side of the angle, so that would be the sine of 40 degrees. All right, and this one here would be 24 nautical miles, the cosine of 40 degrees. Okay, and we could break up this guy the same way, and we're going to use his angles that are given. We're coming down, and then we're going, coming down, and then we're going over. Okay, so here's your right angle. All right, this side here is the opposite, so that would be 18 nautical miles, right, times the sine of 65 degrees. And this one here will be 18 nautical miles times the cosine of 65 degrees. And once we get those, we'll have the components of where we are. So now if you notice, this is a negative, that's positive, positive. So we're looking at a negative over here for the what? Y value, right? Y value. X is going to be positive, X is positive, positive Y up here. So everything's positive up here. This is positive X, but negative Y, okay? All right, let's run these numbers. So let's get this, this one here. The X value would be 65, and we have the sine of that times 18, and that's 16.3. So 16.3. And this guy here would be 65 cosine times 18, and that is 7.6. 7.6. All right, let's get this one. 40 degrees sine times 24, 15.4. Okay, this guy, 40 degrees, cosine times 24, 18.4. Okay, so there you go. I got these values. Let's put them into the D equation. Okay, like I said, I'm using B. So I got 16.3 minus 15.4 squared plus this guy would be minus 7.6, right? Minus 18.4 squared and square root of that. All right, so let's run these numbers in the calculator. 16.3 minus 15.4 is 0.9. 0.9 squared. Okay, let's get this guy. 7.6, okay, negative, minus 18.4 is negative 26. So it's negative 26. Okay, let's square these guys. Negative 26 squared plus 0.9 squared equals, and the square root of that. So distance here is 26.0 nautical miles. All right, 26. So the magnitude of R is 26 nautical miles. All right, let's measure that and see how it comes up. All right, I have about, I kind of screwed up a little bit here on the angle, but it looks like about 8.7 or so. All right, so if it's 8.7 millimeters, right? Let's put it 8.7 millimeters here. So if I have 8.7, this is graphical, okay, graphical, 8.7 millimeters over 1 times what was the amount I had. I would have 3 millimeters. This is my scale factor, is 10 nautical miles. So I say 8.7 divided by 3 equals times 10. So 29, I'm coming up with 29 nautical miles graphically. So it's kind of in line with this, so close enough. My angles are not precise, and there's are most likely. All right, so we have the distance. We don't. Now we need to figure out how what is the xy components of this vector, so we can get the bearing that this guy has to travel. But while we have the distance, let's finish the problem. How long is it going to take this ship B to travel this distance of 26 nautical miles? Okay, 26 nautical miles over 1. So the time he will travel will be time of B to reach A will be 26 nautical miles times what is his speed? His speed is 9 nautical miles per hour. So it's 9 nautical miles over in hours over the top of it. You just conversion. You set up your chain, your multiplication chain here. So it's 26 divided by 9. So 26 divided by 9. Oh, it's a bit of a ride. So we have 2.9 hours. Okay, so what is 0.9 hours? 0.9 times 60 is 54. So 2 hours and 54 minutes. Okay, 0.9 times 60. So that's how much time. Now, assuming they got this message, what time did he travel? This is 2 hours he was traveling. So that's 2 o'clock. So it'll be 4:54 in the afternoon. Okay, 4:54 in the afternoon. So what would that be in military time? 1654 hours. Okay, he would arrive. So there we go. 1 second here. Okay, so that's the time he's going to arrive. Now we have to figure out what course is he going to ride on. Okay, so well, how are we going to break this up, right? To figure out, well, he's at B, he needs to travel to A. Okay, so we don't know that angle, right, at the moment. Okay, so the way to figure it out is we have to break this guy up and look at him as a separate piece here. I'm gonna kind of break it up over here for you. All right, so what is he? He's about this here. I don't know, about 9 millimeters. So I'm just gonna draw it here. So if you draw 9 millimeters here, there he is. Okay, and there's B, and here's A at the given moment. Okay, now we know the length of that. It's 26, right? Okay, and we have the XY components, which are going to help significantly. So the XY components are 15.4. I'll rewrite them, and 18.4. And then this guy down here is 6. All right, so we have the positions of both of these vectors, and the way I'm going to describe this is we have to get the difference between the two, and that gives us the lengths of the legs. So Let's look at this little thought process here. If I put the origin over here, what I'm saying is I'm taking the further point and I'm so this point here, and then I'm subtracting this distance, and that'll get me that little leg, you see? Now in this case, I have this y value here down to the origin, and then this y value here. So you notice you're actually adding the two. So that's why when you subtract, it's going to add the two together. You're subtracting a minus number, it adds together. So there's my xb minus xa, delta x here is 16.3 minus 15.4. I'm plus 0.9 in the x direction from A to B. Okay, so B is further 0.9 to the right of A. Okay, now let's look at the y here. Well, the y is 18, all right, 0.4, okay, minus 7.6. So minus a minus, so I got here 25.6. It might be a little off. I think I rounded off the 18. Let's see, 18.4. 18.4 plus 7.6. 7.6 is 26. So this is really 26 here, not 25. Now, I'm looking for this angle theta here, and when I do, I can get this north, okay, and I know this is a 90 degrees here, and then I know that 90 degrees minus theta will give me that alpha angle, and then I would report this as the bearing, as the ship would be north alpha west. So there's north 10 degrees west. Okay, so in this case, that's the answer. How did I get that answer? Okay, so let's take a look. I have 26 here, which I calculated from here is my ry, right? Why is it ry? Well, it's the opposite, right? It's the ry vector component vector of my r, right? And it's across or opposite of the theta, so I get ry, right, as my magnitude. 20 is 26, so it's really 1. So what do I get here? 1. I get 1 inverse sine. It looks like 90 degrees. So I was doing before I got 25.4, but it turns out it's it should be a little off, so I probably made a mistake. It might be 25.6 here. I'm not sure. So in which case I got 26 sine theta divide 25.6 divided by 26 equals, and I do the inverse sine, and I get 80 degrees here. So 25.6 divided by 26 gives me this, and then I do the inverse sine, and I get 80 degrees. Okay, and then I subtract the 90 minus the theta, gives me the alpha, it's 10 degrees. I report it as north 10 degrees west. It's an almost 90 degree angle. Okay, that closes out this problem. Thank you.